Welcome back to our channel. In the last video, we learned how to deal with constants and constant multiples. Today, we'll learn how to differentiate when a function is made up of two or more terms added or subtracted. These are the sum rule and the difference rules. What do these rules state? Considering the sum rule, it states that if two functions are added, differentiate each separately, then add the results. This can be seen in the first formula, where the differential of two functions f of x and g of x is the same thing as the differential of the sum of two functions f of x and g of x is same thing as the sum of their differentials, that is f prime of x plus g prime of x. Now, considering the difference rule, it states that if they are subtracted, differentiate each separately, then subtract the results. This can still be seen in this formula, which says that the differential of the difference of two functions f of x and g of x is same as the difference of their differentials, which is of their derivatives, which is f prime of x and g prime of x. So this is the law briefly stated here. Now, considering this differentiating using these two principles, that is the sum rule and the difference rule, can be summarized into three different steps. What is the first step? Split the function into separate terms. First of all, for such a function or for these types of functions, we have the sum or difference of many terms. So the first thing we need to do is to split them into different terms in order to either add their derivatives or subtract their derivatives. The second step is to differentiate each term individually. After splitting each term, we then differentiate each term individually. That's, we take the first term, we differentiate, the second term we differentiate, third term we differentiate, and moving on to the third step, which we recombine. That is, we add or subtract the derivatives depending on the sign which we have before the terms. So in order to put all of this into much more practice, to make it more clear, we are going to use an example. So let's start with example 1. Differentiate f of x, which is equal to x4 plus 3x squared minus 5x plus 7. So in order to perform this derivative or this differentiation, we are going to follow the procedure listed above. So we'll take our first step, step 1. What does step 1 say? Step 1 tells us to split the function into separate terms. So when we see this function f of x, we identify four different terms, which is our first term is x4, our second term is 3x squared, third term is minus or negative 5x, and our fourth term is 7. So after splitting it, we have already identified our four different terms. Moving on to the second step, which tells us to differentiate each term individually. That is what we are going to tackle right now. So taking our first term, the derivative with respect to x of our first term, x to the power 4, using the power rule which we studied just above, is the same thing as 4x to the 4 minus 1, which is 4x cubed. Taking our second term, derivative with respect to x of 3x squared. Now, if you remember, this is the constant multiplier rule. So what do we first do? We isolate the constant 3, which gives us 3 times the derivative of x squared with respect to x. Now, using the power rule on this derivative of x squared, we have 3 times 2x, which gives us 6x. Now, tackling our third term, we have the derivative with respect to x of negative 5x. Using the same constant multiplier rule, negative 5 is a constant, so we isolate it outside, giving us negative 5 times the derivative with respect to x of x. And what does this give us? Negative 5 times 1. Why 1? Because the power of x in this case is 1. So we have 1 x to the power 1 minus 1, which gives us negative 5 times x to the power 0, which gives us negative 5, since x to the power 0 is 1. Moving on to our fourth term, we have derivative with respect to x of 7. Using the constant rule, which says that the derivative of any constant is 0, this implies that the derivative with respect to x of 7 is 0. We are done with our second step. Now, if we move on to our third step, which tells us to recombine, that is, add or subtract the derivatives. What does that tell us? The derivative of x, which is f prime, derivative of f of x, which is f prime of x, is the same thing as the derivative with respect to x of x to the power 4 plus the derivative with respect to x of 3x squared minus or plus the derivative with respect to x of negative 5x plus the derivative with respect to x of 7. So from here, we have already calculated this individual derivative. So we'll just take the values which we had and replace them in this function, which gives us 4x cubed plus 6x minus 5 plus 0. From here, we can then conclude that the derivative with respect to x of our function f of x is equal to 4x cubed plus 6x minus 5. So example 1 is complete. Now we are going to move on to a second example, which is more of a practical question, in order to assure, to affirm that the notions which we have covered in this first example is well understood. So taking our second question, practice question 1. Practice question 1. Differentiate g of x is equal to x cubed minus 4 on x plus the square root of x. So I'm going to leave you guys time to pause the video and work on the video. Yes, attempt the question at least and come up with your own answers, and post your answers in the comment section below, and we'll all get down to it with our own remarks and reviews. So starting this question, considering that each and every one of you have already attempted the question, we are going to follow the same procedures we used in our example above. From our three procedures, which are first being split the function into separate terms, second being differentiate each term individually, third being recombine the derivatives, we are going to start with the first term, which tells us to split the function into separate terms. From this function, which is g of x equal to x cubed minus 4x plus square root of x, we can identify three individual terms, with our first term being x cubed, second term being 4 on x, third term being square root of x. So we have already split our function into separate terms by identifying each term. Moving on to our second step, which tells us to differentiate each term individually. We'll start with our first term. Differential with respect to x of x cubed, using the same power rule which we had done in the previous video. It is 3 times x to the power 3 minus 1, which gives us 3x squared. Taking on our second term, differential with respect to x of 4 on x. In this case, I didn't consider the negative because when I'm going to add the different functions, I will then consider the negative sign during the addition or during the addition of the functions. In the previous example, I considered the negative sign directly while differentiating, which led me to perform an addition when I was adding the different derivatives. Is it here? Yes. But in this case, I'm not going to consider the negative, and I'll perform the derivative normally. Then during adding the different derivatives, I will then consider the negative sign. So moving on with this, our derivative, we have differential with respect to x of 4 divided by x. This term can still be written as differential with respect to x of 4 times x to the power negative 1. Now, using our constant multiplier rule, 4 is a constant, so we need to isolate it. This gives us 4 times the derivative with respect to x of x to the negative 1. Now, using our power rule, we have 4 times negative 1 x to the negative 1 minus 1, which gives us 4 times negative 1 x to the negative 2, giving us negative 4 x to the negative 2. Now we're going to continue with our third term, which is square root of x. Differential with respect to x of the square root of x is same thing as the differential with respect to x of x to the power half. We will still use as our power rule to tackle this question, and this can then be written as half x to the power half minus 1, which gives us half x to the power minus half. Having calculated the derivatives of the individual terms, we will then move on to our third step, our third procedure, which tells us to recombine, which is to add or subtract the different derivatives. So from here, we can then perform g prime of x, which is the same thing as the derivative of g of x, is then going to be equal to the sum or difference of these different derivatives depending on the signs we had in the initial questions. So we have d on the x of x cubed minus d on the x of 4 on x plus d on the x of square root of x. Having calculated each of these terms, we will just replace them with the values we obtained during the calculations. Our first value being 3x squared minus our second value minus 4x to the minus 2 plus our third value half x to the minus half. This gives us 3x squared plus 4x to the minus 2 plus half x to the minus half. This then tells us that the derivative with respect to x of our function g of x, which is equal to the derivative with respect to x of, what was g of x? X cubed minus 4 on x plus square root of x is equal to 3x squared plus 4x minus 2 plus half x minus half. So having completed this first practice question, we are going to move on to our second and last practice question. Practice question. So what is this question? This question tells us to differentiate the function h of x, which can be represented as half x to the power 6 minus 7x cubed plus 9. We will still follow the same procedures as we did in the previous questions. So what does our first step tells us to do? Our first step tells us to split our function into the separate terms or to identify each and every term we have in our function. In this function, we can identify 3 different terms. Our first term being half x to the power 6, second term being 7x cubed, negative 7x cubed, or we can just use 7x cubed as it is, and the third term being 9. Moving on to our second step, it tells us to differentiate each and every one of these terms individually. So we're going to start with our first term, half x 6. The derivative with respect to x of half x to the power 6 is same as half, using our constant multiplier rule where we isolate the constant before we perform the derivative, times the differential or derivative with respect to x of x to the power 6. Now, using the power on this term, we have half times 6x to the power 6 minus 1, which gives us half times 6 to the power x5, which then gives us 3x to the power 5. Moving on to our second term, the derivative with respect to x of 7x cubed. Let's add the negative in this case. We could still leave it out, but let's add it here so that for all of us to understand the different methods and all. It's the same thing as we isolate first of all the constant, which is negative 7 times the derivative with respect to x of x cubed. This gives us negative 7 into 3x to the power 3 minus 2, negative 7 times 3x 3x minus 1, sorry, times 3x squared, which then gives us negative 21x squared. Moving on to our third term, the derivative with respect to x of our constant 9. We all know from our constant rule which states that the derivative of any constant, no matter what it is 0. So this gives us automatically 0. So we are done with our second step. Moving on to our third step, which tells us to add or to subtract, that is to combine these different derivatives. We have differential with respect to x of our function h of x is the same thing as the sum of our different derivatives, that is z on the x of half x to the power 6. In this case, we use plus here because the negative was considered when we were calculating the derivative of our second term, negative 7x. So plus derivative with respect to x of negative 7x cubed plus derivative with respect to x of 9, which then gives us 3x to the power 5 minus 21x to the power square plus 0, which gives us our answer 3x5 minus 21x squared. We can then conclude that the derivative with respect to x of our function h of x can then be represented as 3x to the power 5 minus 21x squared. So this is our answer. Now, in order to highlight common mistakes students usually perform here, I was able to highlight 3 different errors. Our first error being forgetting to differentiate each terms. Most of the time, students will let's take the same equation h of x and suddenly forget to differentiate one term, which will lead to a wrong answer. The second step is dropping constants incorrectly. Constants can range from signs to the numbers itself. Like taking this our second term, someone could differentiate without considering the negative sign, which will lead to an obvious error. Another person could consider the second term and differentiate without actually considering the 7, which is still an error. Now, our third error or third mistakes we were able to spot out is missing signs. That is the plus and minus. A plus suddenly becomes a minus, and a minus suddenly becomes a plus. Okay. So that is the end of this video. Thank you very much. See you in our next video.